Product orientation from Schneider Electric.
Studies the levels of electrical current that can harm the human body. So this just displays what the study from IEC shows. So 2 milliamps of current, which is 0.02 amps, is already enough for you to feel this level of current is flowing through you. This doesn't cause any irreversible damage, but you can already have sensation in your fingers if you have this level. Now 10 milliamps can result in now muscle contractions. It's sufficient to result in muscle contractions, but again, this does not cause any irreversible damage to the human body. Now, when we get to 30 milliamps, that's different. Now you can have respiratory paralysis. So 30 milliamps is the threshold that's determined by IEC, above which electric current will cause irreversible damage to people, can result in serious burn, serious injury. That's why the threshold for RCDs is 30 milliamps. So to always keep the residual current below 30 milliamps. And of course, the higher you go now, 80 milliamps is where you can have a heart attack, cardiac arrest, so extremely dangerous. So this is why the threshold of 30 milliamps is chosen for people protection. There are RCDs with higher thresholds, 300 milliamps, 500 milliamps. These are not meant for people protection against electrocution. They are meant for installation protection against the risk of fire. Because when there is a residual current, yes, it can be that someone is touching a live part, but it could also just be that your insulation has broken down. So maybe the insulation of the cable is torn, and then current is flowing to ground. This is still a risk for the installation because it can result in overheating of that insulation and in fire. So you have different thresholds to protect against this at 300 and 500 milliamps. But for people, it has to be the 30 milliamp option. Now here I want to show you, we have these 3 use cases to show you some of the continuity of service that you can get by segregating circuits. So the first one here, all of these you have socket outlets, light circuit, and you have an MCB to protect them against short circuit and overload. So when I press this, it simulates earth leakage fault. So it will inject 30 milliamps into the system. So if I have just an MCB, the breakers will not trip. So it continues to push the person. Now here, you have the first scenario where you have one RCCB protecting the whole installation. So the wiring here is main power. Then this RCB is supplying both MCBs. So this is like the main incomer. Now here you see that the fault will simulate is only on the socket line. So when I simulate it, because the main incomer trips, both the socket line and the light line is powered out. So this, the person is still protected, so this is okay for people protection because you can come back and switch it on and you continue to have power. It's okay for people protection, but it's not very good for continuity because the lights have now been switched off, but the fault was on this other side. And the third scenario is where you segregate the 2 circuits. So you have an RCD MCB pair for the socket outlets, RCD MCB pair for the lights. Now the fault will only happen on this line, and you only trip this side. So the lights continue to operate. So more expensive because you have 2 RCDs, but better continuity of service. You have only the portion that's affected going off. One other thing I'll mention is that all RCDs will always have this test bundle. So the standard requires that an RCD operation must be tested every so often. Usually the requirement is 2 to 3 months. You need to test that it's functioning because this device only really functions when someone is at risk of electrocution. So you don't want it installed there and you are not sure that it's operating. So what this does is that it injects the same current we're doing here, and then if the breaker trips, it means it's working okay. If it doesn't trip, it means it needs to be changed. So, yeah. So how the testing is done is you switch off all the loads, and then you just come and then you press on it. So if it trips, you've confirmed it's still operational, it's still functional, you're fine. You put back the loads on. Even your GFCI socket outlet must have this test button. It's a requirement. So, and when you have at home, you should probably be testing it every now and then, just to make sure that it's still operational. Okay. Yeah, so that's it for this panel. These are just some common hazard areas that are located. So any water points, if you have an electrical outlet close by, bathroom, if you are working with hair dryer, blow dryer, something like this, close to a water point. Appliances in the kitchen, all these are high risk areas.
Okay.
So any questions?
Can I take that for example? Or can I take this? Can I take for my sample?
We can arrange. If you bring people around.
Thank you, sir.